Unit 6, Section 6.3, Area of Composite Figures. So our goal today is to find area of many different objects and break them down into our basics that we did here. So when we look at the area of a composite figure, any figure that is a composite or considered to be a composite figure is any figure that can be broken into regions that are basic figures, like our triangle, parallelogram, trapezoid, rectangles, and circles. Pretty much that day one formula. So to find the area of the composite figure, we divide up the regions and find each area of that, whatever that region is, then find the sum or the total, of that area. So if I had something like this, where I had a triangle on top, I would divide it, find the area here, and then add those two totals together to find the total area of the entire figure. And so that's what we're going to be doing is, instead of having a different formula for every possible shape we could be thrown, we can break it up into more manageable pieces. So we have 4 examples today that are going to break down most of the different ones that we can do, and our practice will be similar. All right, our example, find the area of the shape, round to the nearest hundredth when needed. All right, so here we even have a breakout line where I would say this is broken into a rectangle up here and a trapezoid down here. So if I focus on the rectangle, our area formula is base times height. I have a base here of 23, and then I have a height here they give me that's 12. So the area of just this piece is 276 when I put that in my calculator. The trapezoid area, we need base plus base divided by 2. So if I look, the base here of the trapezoid is that same 23 as the rectangle, plus 15 here. All of this times a height. Okay, well that 18 is all the way, and so I just want this measurement from here to here. That would be the right measurement here. So the 18 is good and the 12 is good, but what about this distance, that height that I want here? If I take 18, which is that entire piece, and subtract 12, I can get the 6, so that when those two add together, they get me the 18. So the height of just my trapezoid is 6. And when I put this in my calculator, it tells me that the area of this region now is 114. So once I found the rectangle and the trapezoid, I can find the total, which is going to be that 276 plus the 114 to make it the entire figure. And when I add those together, I get 390, and my units are centimeters squared. Okay, let's look at number 2. Okay, now I see a basic rectangle here. So I see my rectangle. I also see a triangle here as my second object. And down here I see a semicircle. All right, so I'm going to break it into those 3 pieces where I have a triangle, rectangle, and semicircle. So the first one, let's focus on the rectangle, where it has a base of 9 times a height. Okay, well, we need this length. So all the way down from here, all the way down is 26. If we know this is 9, okay, now I'm going to use my circle. A radius should be the same no matter where it is. So if I find this entire length here, 7 plus 9, that's going to give me my 16 here. Ooh, actually I don't know if that's 9. I need to do this way, because that looks longer than 9, right? Because it doesn't say that's part of the circle. So I know this part is 9. All right, so now I'm going to think over here. So I have 7 plus something plus 9 gets me that whole 26. And so when I take that 26 and I subtract the 7 and the 9, that's where I get a height of 10. So now I have 10 here. Oops. Got ahead of myself here. 10 here. All right, are you following? So I use the circle, radius, radius, radius. This is not a radius because it goes up a little bit further than actually the 9 does. And so that's where I needed to use this entire length of 26, the 9, the unknown, and the 7 to find this height. The actual height of our rectangle, when we finally get there, is 7 plus 10, 17. So that took us a little bit, but keep working. And if it doesn't make sense, let me know, and we'll keep working at it to make it make sense. But the triangle, now that we've done that work, now we have the base and the height divided by 2 for the triangle. So 90 divided by 2, I get 45. And then the semicircle, that's going to be pi r, which we have as squared, and then divide by 2 to make it a semicircle, which gives me 81 pi over 2. Once I find the areas of my regions that I've divided, a rectangle, a triangle, and a semi, that's all of this together. So I'm going to add those together. 153 plus 45 plus 81 pi over 2. And so when I put this in my calculator, rounding to the nearest hundredth, I get 325 and 23 hundredths with units of feet squared. All right, on number 3. Kind of looks like an ice cream cone here. So I see kind of a break here with a triangle down here and a semicircle up here. So I'm going to start at the top, and I have, 16 is all the way across, so I know my radius here. Divide in half is 8 and 8. So pi 8 squared. Divide by 2 because it's a semicircle. So my calculator tells me I get 32 pi. And on the bottom, I have a triangle where I need base times height. Okay, so my base is 16 and my height is here. So how is this measured? It's not 17. It's tempting to use the 17, but I can't use the 17 when it's slanted. I need that perpendicular to my base idea before I can divide by 2. So what's nice is that we have done a unit on these types of triangles where we have an unknown here, 8 something and 17, where I can go over here and do 8 squared plus h squared equals 17 squared. H squared, when I take 17 squared minus 8 squared, is 225. Square root both sides to get h by itself, and I get 15. So the height on this one was also hidden, but not in a total idea, in a Pythagorean triangle idea. And then once I do 16 times 15 divided by 2, I get 120, which allows me to find my total by adding the 32 pi plus the 120. This would be the exact answer, but since it's asked us to approximate to the nearest hundredth, we can put this in our calculator and get the decimal. 220.53, and our units here are meters squared. So if I put 32 pi plus 120 in my calculator, it gives me that decimal. This would be the exact answer without rounding. And on our last one, I see a rectangle, and I see a, let's see, or maybe that's a square. Sides are the same. So I see a square, a trapezoid, and a triangle, or maybe 2 triangles. But I think those are the same, and I can see it as one whole triangle. All right, so I'm going to say those are my breakdowns. I see a square, then I see a trapezoid, and then I see a triangle. So breaking it up into these regions. So if I look at the area of the square, all right, so I have all the way across here by here. So I need base times height. So right now I have this, but I don't know what it is. And this length, but I don't know what it is. So what can I do to find that piece? Well, I'm going to go over here and look at my triangle because I can do Pythagorean theorem with triangles but not with squares. So if I have 9.6 and 12, I'm going to do 9.6 squared plus some unknown squared equals 12 squared. Okay, I'm going to take 144, 12 squared minus 9.6 squared, and I get 51.84. Square root that, and I get 7.2. So this distance is 7.2, which means this distance is 7.2. And now I know my entire distance is 14.4, which is what I needed for the square. To take base 14.4, and this is going to be the same measurement, 14.4. And once I have that in my calculator, I can multiply those two and I get 207 and 36 hundredths. All right, so now my trapezoid, I have 14.4 from our triangle, or I'm sorry, from our square. And the trapezoid area is going to be that base, so 14.4 plus the other base, which is 10, divided by 2 times the height. Okay, so how tall is it from here to here? All right, well, we're going to go all the way as 25.4, and we already know 14.4. So to find this piece, I'm going to do 25.4 minus the 14.4. And I get 11. So the height of the trapezoid is 11. Put that in my calculator to find the area, and I get 134.2. Okay, so now I have two parts taken care of, and I need to do my triangle. Triangle, I don't think I'm missing any more measurements here. I have a base of 4, putting those two together, times a height that's perpendicular, which is 9.6, divide by 2 for a triangle. And when I put that in my calculator, I get 69.12. And so the total, now I'm going to take the 207.36 plus the 134.2 plus the 69.12. Adding up all of those pieces to get a grand total of 410.68 meters squared from my meters here. So the formulas themselves are not new. That's what we've practiced before. The new part is maybe finding missing pieces using Pythagorean theorem or using entire lengths and subtracting what we know to find what's left over to find those missing pieces. Our practice tonight should be similar, but it won't be these exact problems because there's lots of ways to make composite figures. Let me know if you need help, and I hope you have a good day.